Hello everyone, myself Professor Rakesh Patil from the Department of Civil Engineering, KLS VDIT Haryad. I welcome you to the lecture series on groundwater and hydraulics. The subject code is 17CV742, 7th semester, module number 4, and today we are going to discuss about lecture number 26. Before going to start with the today's class, I would just like to brush up the things which we have discussed in the previous class. In previous class, we have discussed the groundwater exploration by means of physical method and geophysical method and by means of geotechnical methods. In today's class, we are going to discuss about geophysical exploration. So, what do you mean by geophysical exploration? It's a gravity measurements that have anomalous density within the earth crust. In the most cases, ground-based gravimetric are used to precisely measure variation in the gravity field at the different points. That is geophysical exploration. In today's class, we are going to see how the geophysical techniques are helpful to understand the ground behavior, whereas by means of water or by means of different soils or by means of different rock stratas. In today's class, we are going to discuss about some of the electrical loggings. Those are called as geophysical loggings. In geophysical loggings, we are going to discuss about some of the electrical logging, radioactive logging, induction logging, and sonic logging and fluid loggings. Water is one of the most vital resources in the area where surface water is not available. Groundwater constitutes a significant part of active freshwater resources of the world and is dependable source for all the needs. Geophysical investigation involves simple method of study made on the surface with the aim of accelerating subsurface detail. This is achieved by measuring certain physical property and interpreting them mainly in the term of subsurface geology. Groundwater exploration project pass through various surveys. The main objective of this survey is to study and understand the hydrological cycle of the region, to understand overall concept of type, nature, number of aquifer, and quantity of groundwater. Different interference to suit different proposes can be drawn from the same field data. For example, electric resistivity data can be interpreted by knowing subsurface of rock types, geophysical structures, groundwater condition, ore deposit depth to the bedrock, etc. Hence, the investigations are multiple purpose. Applications of geophysical techniques are investigations are geophysical exploration are numerous, important and widely varied. Investigations aim to locating and estimating economically important mineral deposits. Investigations aim to locating and ascertaining groundwater potential and its quantity. Investigations aimed at solving problems connected with geology. Geophysical methods are geophysical exploration is a scientific measurement of physical property of the earth crust for investigation of mineral deposits or geological structure. Geophysical methods detect in differences in the physical property within the earth crust. Density, magnetism, elasticity and electrical resistivity are properties most commonly measured. Types of geophysical methods. Electrical methods. Electrical methods are numerous and very more versatile. They are more popular because they are successful in dealing with a variety of a problem like groundwater study and subsurface structure. Electric methods are based on the fact that subsurface formation, structure, ore deposition, etc. possesses different electric property. These differences are investigated suitably and exploited to draw the necessary conclusions. Electrical resistivity method. All the geological formation have a property called electrical resistivity, which determines the ease with each electric current flow through them. This resistivity is expressed in the unit of ohms meter and indicated by the symbol of P. Electrical method, the electrical resistivity method, the electrical resistivity of a rock formation limits the amount of current passing through the formation when an electrical potential is applied. Resistivity of the material is equals to uh, resistance sectional area divided by length of the wire. Resistivity, electrical resistivity is resistance of a volume of a material to the flow of electrical current. Current is introduced into the ground through a pair of electrodes. Resulting potential differences is measured between another pair of potential electrodes. Apparent resistivities can be calculated through the given values. This is how electrical resistivity method will be present. We have 4 electrodes here, 2 current electrodes and 2 potential electrodes. Current electrodes connected with a current source, whereas potential electrodes will be connected to the voltmeter. Then whenever current passes and volt passes, that time all the different phases give the waves, that is P wave and S waves, primary wave and secondary waves. The profiling and sounding are two types of resistivity investigation. Profiling is done to detect lateral changes in a resistivity. This study reveals the changes in the subsurface lithology or a structure from the place to place. Sounding is done to determine the vertical changes in resistivity. This study reveals changes in the lithology at a particular place with increased depth. Then we have a different configuration, that is Wenner and Schlumberger. In Wenner, setup of 4 electrodes are placed in the line on the surface, 2 for energizing the earth and other 2 are measuring the resultant voltage. This is Wenner method. And Schlumberger, this was developed in the year of 1916. This method is measured the potential gradient rather than the potential differences. For the purpose of potential electrodes are kept at the smaller separation compared to the current. This is how Schlumberger configuration can be inserted. Next, sounding. The sounding method is popularly known as vertical electrical sounding. It is also described as a depth probing, electrical coring, etc. In this method, the resistivity value Pa is measured at the same place by increasing the distance between the current electrodes each time after taking readings. This kind of succession increases in distance makes the current penetrates more and more deeply. Hence, the changes in Pa value measured indicates the vertical variation in the subsurface at the investigated point. Thus, the sounding technique is useful in investigating only horizontal or gently inclined structures. Inverse slope method. This semi-empirical method is mostly used in drought-prone areas where the water table is very deep. It is simple operate and gives good result. Seismic refraction method. In seismic method of prospecting, artificial explorations are made and elastic deformations are induced in the rock present in the ground. The propagation of such seismic waves through geological forms, that is geophones. Seismic refraction method. Depending upon the weather, reflected waves or refracted waves are used in the investigation. There are two types of methods, namely seismic refraction method and seismic refraction method. The basic component of seismic instruments are meant to take into account the chief functions involved in the prospecting. These chief functions are detection of signals, differentiation of signals followed by the applications. Third one is recording of that signal. These functions are prepared by the geophones, amplifier and galvanometers. Instruments used in seismic studies. The geophones, that is detector, which is planted in the ground, picks up signal and depending on the consequent ground displacement velocity gives out a proportional voltage. This voltage, after undergoing unwanted frequency filtration, is amplified in electric current. This is done by amplifier. The voltage is fed to seismic galvanometer, which has the mechanism to give out a trace of signal on the photographic paper. This is how geophones look like. Okay, in this diagram you can see the seismogram will be kept here. Then from the seismograph wire will be brought to the source. Then one geophones can be kept here. Then the reflection may be observed. These are the geophones which we have kept here. 24 geophones at the different areas. These are the reflected seismic waves and these are the refracted seismic waves. All through the groundwater cannot be seen on the earth's surface. A variety of techniques can provide information concerning occurrence of groundwater and even its quality of surface or above surface location. In this we have different methods. First one is gravity method. Gravity method measures defines anomalous within the earth. In most cases ground based gravimetric are used to precisely measure variations in the gravity field at the different points. Next one is magnetic method. This magnetic method exploits small variation in the magnetic mineralogy, that is magnetic iron and iron titanium excites minerals. Among the rocks, measurements are made using flux gate, proton precession, Oberheisers and optical observation magnetometers. Next one is gamma ray method. Gamma ray methods use scientific to identify the presence of the natural radioelements potassium, uranium and thorium. Multiple channel spectrometer provided measures of individual radiometric abundance. Seismic method technology have had relative limited utilization due to their relative high cost and the difficulty of acquiring and interpreting seismic data in strongly faulted and altered igneous terrains. Next one is thermal method. Two distinguished techniques are included under the thermal method. One is borewell or shallow probe method for measuring thermal gradients. Second one is airborne or satellite based measurements. Next one is electrical method. Electrical method comprise multiplicity of separate techniques that employ differing instrument and procedures, have variable exploration depth and lateral resolutions, and are known by the large lexicon of names and acronym describing techniques and their variants. Electrical methods can be described in 5 classes: direct current resistance, electromagnetic constants, induced polarization, miscellaneous conversation, self potential. So that's all from today's class. In next class we'll see another topic. So that's all from today's class. Thank you very much.